what is the difference between structure, geometry and shape? Okay, consider a molecule ClF3. একটা molecule ClF3 নিলাম এবং ClF3 তে আমাকে যদি বলে যে write its structure or what will be its geometry or what will be its shape, তাহলে কি হবে, কিভাবে দেখা? এটা প্রচুর কনফিউজ করে যে যখন আমাকে স্ট্রাকচার লিখতে বলা হয় তখন আমি করে দিই, হয়তো হতে পারে যে সেভ করে দিলাম। যখন আমাকে জিওমেট্রি জিজ্ঞাসা করা হয় তখন আমি হয়তো করে দিলাম কোনো একটা স্ট্রাকচার। সো ইটস ভেরি ইম্পর্টেন্ট টু নো দিস থ্রি টার্মস লাইক স্ট্রাকচার, জিওমেট্রি অ্যান্ড শেপ। সি, when we will talk about structure, we will draw only Lewis structure. Lewis structure. In Lewis structure, what we will do, we will count sigma bond pair and lone pair of electron. Sigma bond pair and lone pair of electron. And we will just show the sigma bond pair electron, lone pair of electron. Of course, in Lewis structure, we will show the pi bond pair also. Okay. So, how to get the sigma bond pair, pi bond pair and lone pair of electron? First, I am going to show you the structure of ClF3. In order to know the structure of ClF3, what I will do, I will first calculate the steric number. So first I will calculate steric number. Steric number is basically sigma bond pair plus lone pair of electron, sigma bond pair and lone pair of electron. Okay, while drawing structure, we will also consider pi electron, means pi bond pair also we will show while drawing structure. Okay, let me explain this one, the ClF3. In ClF3, how many numbers of bond pairs and how many numbers of lone pair electrons are there? So in order to calculate, first what we will do, we will calculate total valence electron. So first calculate total valence electron. How many numbers of electrons are there? Total valence electron 7 plus 3 multiplied by 7, that is 28. Now you simply divide it by 8. Okay, this is basically sigma bond pair. This value will give you sigma bond pair, and this will give you lone pair, right? So sigma bond pair আর lone pair আমি পেলাম, এখানে কোনো pi bond pair নেই, that I know. There is no pi bond pair. Now, if I want to draw the structure, how I will draw the structure, or how I will show the geometry and how I will show the shape. So first let me draw the structure. Okay, in ClF3, 3 sigma Bt plus 2 lone P. Hybridization is sp3d because steric number is 5. Hybridization is sp3d because steric number is 5. For steric number we will calculate only sigma bond pair and lone pair. Now let me draw the structure of ClF3. Same. Okay. ClF3. Okay. 3 sigma bond pair and 2 lone pair of electron. Right? Okay. If someone draw like this way and some other student draw like this way, Cl, F, 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 F. Maybe some other student can also draw like this way, Cl, this is lone pair, this is lone pair, F, 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 or else this is lone pair, this is lone pair, this is F, F, F. Which one will be the correct structure? The question is, which one will be the correct structure? See, here all the structures are correct. প্রত্যেকটা স্ট্রাকচারই কিন্তু ঠিক, এটাও ঠিক, এটাও ঠিক, এটাও ঠিক, এটাও ঠিক, এটাও ঠিক. All the structures are correct. So what do you mean by structure? Structure মানে structure আমি যখন দেখাবো, when I will show you the structure, I will draw the structure, I will only pay attention on total number of bond pairs that we have to calculate correctly. We must get the right information about bond pair, means sigma bond pair, lone pair of electron, or pi bond, whatever bonds are or lone pair of electrons are present. After that, after you get the lone pair of electron and bond pair, anywhere you just put the bond pair or lone pair of electron as per your wish. যেমন তোমার মনে হবে ভাই, যেমন তোমার ড্র করতে মনে হবে, as you feel, like the same way you just put the lone pair and bond pair. Don't bother about anything. That will be the correct structure, provided that number of lone pair of electron and bond pair, that calculations must be correct. You should not do any mistake on that calculations. That will create your problem. That won't be the correct structure. So this is also okay, this is also okay, this is also okay. Now in ClF3, like we are familiar with, so ClF3 looks like this. On that book, any book, it is given like this one. See, this is also a structure, this is also a structure. Whatever I have shown you earlier, that is also a structure. So what I am trying to say, structure means Lewis structure. Don't bother about orientations of lone pair or bond pair. No need to consider about the lone pair or bond pair. Okay. Now come to geometry. When we will talk about geometry, see, geometry or electronic geometry. Electronic geometry. See, in geometry, we will consider both lone pair and sigma bond pair. We will consider both lone pair and sigma bond pair, and orientation is important. Orientation is important. How do we get the geometry? Say for CLF3, what will be the geometry? In order to get the geometry, first you have to get the idea of only sigma bond pair and lone pair of electron. From that you will get steric number, and from that you will get hybridizations. Once you will get the hybridizations, you will have an idea like how the hybrid orbital in a particular molecule, hybrid orbitals are arranged in a space. Hybrid orbital গুলো কেমন আছে একটা পার্টিকুলার হাইব্রিডাইজেশন পেয়ে গেলেই আমি জিওমেট্রি পেয়ে যাব, দ্যাট ইজ ফিক্সড। কিরকম? For CLF3 ভাই hybridization is sp3d. If hybridization is sp3d, that means okay, I will draw it here. That means it's like this. Means hybrid orbitals are arranged in this fashion or in this orientations. 1, 2, 3, 4, 5. This is central atom. So in this case, geometry will be for CLF3. Geometry will be trigonal bipyramidal. I got the informations of what? Hybridizations. That hybridizations is sp3d, hybridizations, steric number 5. Once I got the hybridizations, that hybridized orbital are arranged in a definite orientations, definite locations. You cannot put hybrid orbital anywhere. What I am trying to say, if it is sp3d hybridized orbital, so 5 hybridized orbital will be arranged in a proper orientations, and it will give you TBP geometry, trigonal bipyramidal geometry. So we'll consider both the lone pair and sigma bond pair. We won't count the pi bond pair. Later I will show you that. Now, how about the shape? What will be the shape for CLF3? Is it trigonal bipyramidal shape? Is it TBP shape? No. This is not TBP shape. This is not trigonal bipyramidal shape. Geometry or electronic geometry is TBP. So how about the shape, or what will be the shape? In order to know the shape, right? Shape জানার জন্য লোন পেয়ারের রোল আছে। Lone pair determine the shape. Carefully listen. Lone pair determine the shape. But when we will show you the shape, or we will tell you the shape, that time we won't look at lone pair. We will only look at a bond pair. However, lone pair or bond pair you have to arrange in such a way that lone pair will or bond pair, they will fill, or they will have the minimum repulsions. I cannot put lone pair anywhere. I cannot put lone pair anywhere. In proper directions or proper place, you have to put the lone pair of electron. In case of ClF3, how you will put the lone pair or bond pair? Means F and lone pair. Two pairs of lone pair of electron and 3 bond pairs. Okay. We will use here Bent rule. Bent rule. Bent rule. What Bent rule says? Bent rule says that electronegative element will occupy a positions where percentage of its character is less, and lone pair will occupy positions where percentage of its character is high. Okay, clear? See, Bent rule I will discuss in separate lecture. এখন শুধু দেখি যে লোন পেয়ার কোথায় আছে, বন্ড পেয়ার কোথায় আছে, based on these two rules. This is basically Bent rule. So, in ClF3, right? ClF3 তে, okay, this is ClF lone pair, this is bond pair. Okay. See what Bent rule says, that electronegative element will occupy a positions where percentage of its character is less. Actually, in this hybridization, later we will discuss. In this hybridization, basically, although it is sp3d, however, this is sp2 plus pd. This is sp2 and this one is pd. So percentage of S character here almost 0, no percentage of S character. So electronegative element where will be placed or will be positions where percentage of S character is less. So electronegative element will be in axial positions and lone pair will be in the equatorial positions. See, in TBP geometry, you just put lone pair in equatorial positions. Okay, lone pair in equatorial positions and electronegative element axial position. That's all. For time being, you just remember this one. Later we will discuss Bent rule. Okay, now look at this structure. If we want to say the what will be the shape, এটার shape কি হবে? In order to know the shape, don't consider this one. Don't consider the lone pair of electron. You just simply remove the lone pair of electron. See, lone pair determine the shape. But while telling the shape, while looking at shape, don't bother about lone pair. How does it look? It's a light t-shirt. ClF3, ClF, ClF, F, lone pair, F, anything. This is the structure. This is the meta structure. Egulo structure. Dutoi character. What will be the geometry? Geometry is TBP because sp3d hybridization is sp3d. What is the shape? Shape is T-shape. if you understand this one, we will now discuss one by one, like different hybridations and different structure, different shape, okay, and different kind of geometry that I am going to discuss now. So please understand, try to understand this one very well. Then only in the next slide it will be very clear to you. One more information I will tell you, that when there won't be any lone pair of electron, see, presence of lone pair, molecule will be distorted, okay, if lone pair is present. And if lone pair is absent, geometry will be equal to shape. Lone pair is absent, no distortions, geometry will be equal to the shape. Okay, now I am going to move in the next slide. See here. Static number, lone pair plus sigma bond pair. Okay, 2. Hybridization is sp. If hybridization is sp, geometry will be linear. Sigma bond pair plus lone pair 3. Hybridization is sp2. Geometry is trigonal planar. But in this case, shape is equal to geometry if no LP present. If static number is 4, then hybridations will be sp3 and geometry will be tetrahedral. Shape could be tetrahedral or V-shaped. It could be tetrahedral or V-shaped or pyramidal. In this case also, here trigonal planar, the shape will be either trigonal planar or bent. I will show you later. If hybridization is sp3, then geometry will be TBP, and if hybridization is sp3d2, then geometry will be octahedral, and if hybridization is sp3d2, then geometry will be pentagonal bilateral. So whenever we will calculate after we calculate the lone pair and sigma bond pair of electron, we will calculate the hybridations. From the hybridization straightforward, we will mention the geometry. But shape could be equal to the geometry. That entirely depends on whether lone pair will be present or not. If lone pair is present, then shape won't be equal to geometry. Okay. Move to the next slide. In this case, geometry and shape for static number 2. See, if I take one example, anything you can do. Take. Okay, BCl2. How we can calculate the static number? Okay, total valence electron 2 plus 2 multiplied by 7 is equal to 16. If you divide it by 8, that will give you 2. So static number 2 means sp hybridized. Shape you could write like draw like, okay, BCl2, BeCl2, BeCl2, like that. These all are structure. There is nothing wrong in it. So these are the structure for BeCl2. Now, what will be the shape and geometry of the BCl2? See, geometry SP hybridized means it will be linear geometry. So, BCl2, I will show you BCl2, it's like this. This is the geometry. You cannot write Cl here or Cl here. The angle must be equal to 180 degree because it is SP hybridized, and shape also linear. Shape also in this case you just shape is linear. So this will be the shape. Okay, you just put lone pair of electron here. Okay, so here shape is equal to geometry. Here you can say that because shape is equal to geometry. Why? Because there is no lone pair of electron on central atom. So it is sp hybridized, geometry is linear, and shape is equal to the geometry. Okay, it's clear. In case of CO2, okay, let me show you only CO2. In case of CO2, see, CO2, the structure is CO2, the structure is C double bonded O. This is the structure for CO2. Okay, while drawing the structure, you have to show the pi bond. You have to show the pi bond. You must show the pi bond, sigma bond, lone pair of electron. Everything you need to show. Now, whether you will put double bond here or double bond here, it doesn't matter. You can't put it anywhere. Okay, this will be the structure. For geometry and shape, don't consider the pi bond. Don't consider the pi bond. You can show like this. Nothing wrong in it. Because while talking about geometry or shape, we are not bothered about pi bond. So here geometry and shape is same. It's a linear because there is no lone pair of electron on central atom. Okay, যখন shape বা জিওমেট্রির কথা বলবো তখন পাই বন্ড থাকলো কি না থাকলো ডোন্ট কেয়ার, কিন্তু স্ট্রাকচারের সময় পাই বন্ড কিন্তু দেখাতে হবে। How many numbers of pi bonds are there? How many numbers of lone pair of electrons? Everything you need to show. That will give you the genuine structure. While writing the structure, you have to show all these things. Now, how you will put, orientations, don't bother about orientations while writing the structure. Okay. It will be clear for this case. Geometry and shape for steric number 3. When steric number is 3, what will be the geometry and shape and structure? Okay, I will discuss only BX3. Okay, let me show you like BCl3. So what first I will do, I have to get the informations of sigma bond pair, lone pair, pi bond pair, then only we can draw the Lewis structure. See, I have already made 3 videos on Lewis structure. Please go through it, then you can draw. I will just simply draw, later you just check it. Okay, just write like, okay, B Cl Cl Cl. Okay, B Cl Cl Cl. Okay, B Cl Cl Cl. All are correct structure. These are the correct structure. Okay, no problem. Okay. What will be the geometry? See, BCl3, total valence electron is 24. So, steric number will be 3, because if you divide it by 8, you will get 3. So, this is sp2 hybridized. Once you will get the hybridization sp2, it will be trigonal planar. This is the trigonal planar. Okay. So for sp2 hybridizations, the geometry will be trigonal planar. What about the shape? Shape will be also trigonal planar. Why? Because there is no lone pair of electron. So shape will be, shape. So this is Cl, and this is boron. So BCl3, the shape is equal to geometry, and that is trigonal planar. Nothing wrong in it. It's very simple. Okay. When studying number 2, there will be another case. Okay. See. SO2. In case of SO2, the structure will be is double bonded O, lone pair, is double bonded O, lone pair. Okay, this is the structure. 1, 2, 3, 4, 5, 6. 6 electrons are there around sulfur, so it's a correct Lewis structure. Okay. Geometry here. See, in order to know the geometry, total valence electron, if you calculate total valence electron, say 6 plus 2 multiplied by 6, 18, you just divide it by 8, 8 2s are 16, do it, 2 1s are 2, 3. So geometry in this case also trigonal planar. But what will be the shape? Let me draw you the shape and show you the shape. So while drawing the shape, don't bother about pi bond. Pi bond has no role to determine the shape. See, first you just put this lone pair of electron. Now while looking at shape or telling the shape, just remove this one. See, lone pair is just like host. You cannot see the lone pair. So while telling the shape, you just simply remove this lone pair and look at this. What will be the shape? This is basically V or angular. This is a kind of V. So shape is V shape. V or angular. You can say bent also, no problem. See here, due to this lone pair, the shape is not equal to geometry. Don't look at this one while writing or looking at the shape. Okay. Now case number this one, or steric number 4. In steric number 4, see, in every case we will say the geometry is tetrahedral because hybridization is sp3. Whenever the habitations will be sp3, you just blindly tell that geometry will be tetrahedral. But say it could be same or different. That entirely depend upon that whether lone pair is present in these molecules or not. See, CH4, 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 and CH4, there is no lone pair of electron, no LP, no LP. Okay, so here geometry equal to same. Geometry equal to same. Perfectly alright. In case of this one, say NH3, NH3. In case of beta NH3, geometry is tetrahedral. Geometry is tetrahedral. But here shape is not equal to geometry. Why? Because one lone pair is present. One lone pair is present. So whenever lone pair will be present, the distortions will arise. So in this case, the shape will be okay. Let me draw that. Shape will be pyramidal. Division H, and lone pair. Don't look at this lone pair while talking about shape. See, because of lone pair, the distortions arises. Regular geometry become the irregular. But while looking at the shape, we should not bother about this lone pair. So this one, how does it look? It is basically pyramidal. It's a pyramidal. This is pyramidal. So shape is pyramidal, but geometry is tetrahedral. Okay, I'll show you how does it look. Just look at this one. Okay, look at this one. Look at this one. You can see that. See, nitrogen, this is hydrogen, hydrogen and hydrogen. Look at carefully. And this is the lone pair. Don't look at this one. This will give you the pyramidal shape. This will give you a kind of pyramid. It's a pyramid. So this is ammonia. Shape is pyramidal. But 4 bond pairs are there. 1, 2, 3, 4. So geometry is tetrahedral. Okay. Now next move to this one. H2O. See, H2O, in case of H2O, 2 BP plus 2 lone P. So steric number 4, geometry tetrahedral. Shape. Okay, let me draw that. Oxygen, this is hydrogen, lone pair of electron, this is lone pair of electron. Okay. So what will be the shape? See, first of all, shape is not equal to geometry here. Shape is not equal to geometry because lone pair are present. 2 lone pairs are there. 2 lone pair ache. Look at here. See, 4 bond pairs. 1, 2, 3, 4. Okay. 2 lone pair, 2 one pair. So 2 lone pair, 2 one pair. So 4 pairs. So this will be, see, these are arranged in a tetrahedron. 1, 2, 3, 4. Okay. Now don't look at this one. What will be the shape? What will be the shape? Just look at here. I don't know whether you can see it or not. So this will give you the V shape or bend. So the shape will be here, beta. Shape will be V or bend. Huh? Clear? Clear? I think it's clear. Okay. Can I proceed? Okay. Next. Static number 5. For static number 5, the shape and geometry of static number 5 is very important. Every shape, every orientations or every positions of lone pair and bond pair, you must be very careful while putting that. This is one of the most important geometry and shape for static number 5. Okay. See. So PCl5. So PCl5, total valence electron in this count, it will be 40, 8 5s are 40. So static number 5 means sp3d hybridizations, means geometry TBP, no doubt about it, geometry TBP. Okay, no lone pair of electron, so geometry equal to same, no problem at all. So what will be the geometry for PCl5? TBP, same TBP. Likewise PCl3F2 also be like this. Okay, PCl3F2 I will draw. PCl3F2 I will draw. How does it look? It looks like, see, in order to draw the PCl3F2, you must know the bend rule. See, in what bend rule says, the modal co-negative element will prefer to occupy the positions where percentage of its character is less. So here percentage of its character will be less. So this will be F, this will be F, this is Cl, this is Cl, this is C. Okay. I will show you the structure. This is very important. I will show you the structure and angle also I will show you. Okay. This is PCl3F2. Okay. To know the shape of PCl3F2, look at here. Look at here. Look at here. See, this is the structure, the shape of PCl3F2. See, this is P, central atom, Cl, Cl, Cl. This is trigonal plane, equilateral triangle. This one 120, 120, 120. And one more Cl2 here. One Cl here, one Cl here. Okay. How many 90 degree angles are here? Say 190, 290, 390, and from here 1, 2, 3. So 690 degree angles. So this is the shape of PCl5. Look at carefully. Look at. I think you can see that. You can see that. P, Cl, Cl, Cl. Okay. This is trigonal plane. Why it is trigonal bipyramidal? Because this is trigonal plane. From here one pyramid, from here one pyramid, and from the bottom one more pyramid. So this is trigonal bipyramid. So this is the structure, shape of PCl5, trigonal bipyramidal. Can you see that? 120, 120, 120, 90, 90, 90, 90, 90, and one more 90. Clear? Okay. Now next move to this one, SF4. I'll show you only SF4. Rest of the things you just structure, you just try by yourself. SF4. I'll show you SF4. See, in case of SF4, how to calculate the hybridations? Total valence electrons 6 plus 4 multiplied by 7, that will give you 34. So 8 4s are 32, 2, 2, 1 and 2. So steric number 5. So geometry trigonal bifurcated. Shape is not equal to geometry because LP is present. LP is present. Now what will be the shape of this molecule? In order to know the shape of this molecule, see, I will draw first and I will explain. Okay. This is S. Lone pair will try to occupy positions where percentage of S character is more. See, angle is greater, percentage of S character will be also more. See, here 120 degree angle, here 90 degree angle. So lone pair will preferably occupy in these positions. Lone pair needs basically more pace. Okay, so lone pair will be occupying here. I mean in equatorial positions. So you put lone pair. Okay, if I put lone pair here, what you will get? See, let me put it. This is lone pair. This is F. This is F. These are in equatorial positions. These are in equatorial positions. And in axial positions, you will just put 2 more F. Okay, done. 2 more F. It's done. Now, the geometry is TBP because hybridations is sp3d. Here, this one. What will be the shape? See, look at this one. While looking at shape, don't consider this one. Remove this one. Lone pair দেখা যাবে. Don't you feel that it's like a seesaw? Don't you feel that it's a seesaw? It's a seesaw. I don't know whether you can see or not. This is seesaw. Okay. So এখানে shape লিখবো seesaw. Let me write it here. This is better. Seesaw. Or else we can write remove this one. It's a like K shape, right? K. See, it's a K. Or K you can write. Or you can write like pi shape. So either seesaw, K, like this is K, or pi, this is pi. Okay, done. Okay, the other structure, say, you just draw by yourself. Okay, now next move to CLF3. Already CLF3 I have discussed. Now let me show you here. This is CL. Okay, this is F. This is F. One lone pair of electron. Okay. See. Sorry. See, lone pair will repel this bond pair, and this also repel the bond pair. So here 100 angle won't be 180 degree. Rather, better I'll show you like this way. and this angle, it is observed that this angle is 175. Okay, this is not 90 degree, this is not 90 degree, this angle is 87.5, and this is also 87.5 degree, and altogether it will give you 175. You can check it. Okay, right. So what is the shape? Remove this one, T shape. So shape is T, geometry is trigonal bipyramidal, and shape is not equal to geometry. Done. Next one. Okay, XCF2, say, okay, I3 minus anything, XCF2 also you can, okay, I3 minus, draw I3 minus. Three multiplied by 7 plus 1, that is 22. 8 2s are 16. 6 2 3 6. Okay, 2 sigma BP and 3 lone pair. So stating number 5, geometry trigonal bipyramidal, shape is not equal to geometry. Now we will look at the shape. Shape come on. Okay, in order to know the shape, okay, after this it's clear to you, right? Beta? Okay? Okay. Beta, draw. Let me draw it, okay? I3 minus. But I told you that lone pair will try to occupy in a position where percentage of S character is more. যেখানে অ্যাঙ্গেল বেশি সেখানে লোন পেয়ার থাকবে, লোন পেয়ার কোথায় থাকবে বেটা? লোন পেয়ার ইকুইটোরিয়াল পজিশনে থাকবে, কারণ এখানে অ্যাঙ্গেল 120 ডিগ্রি পাবে। So put one lone pair here, one lone pair here, and another lone pair here. Now what will be the shape? While looking at shape, remove this one. Don't look at this 3 lone pair. Isn't it linear shape? Isn't it linear shape? So shape is beta, shape is shape is linear. Okay, no problem. XCF2 also like that. XCF2 also you can write like this. This is XC, this is F, this is F. One lone pair, two lone pair, three lone pair. See, 2 4 6 7 8, 2 4 6 7 8. So this is also linear. Shape is linear. Shape is linear. Geometry is not linear, beta. In this case, geometry is TBP. So whenever stating number will be 5 beta, geometry will be same, TBP. But shape will be different. Here shape is equal to geometry. Now next move to stating number 6. In stating number 6, okay, consider SF6. Total valence electron 48, 86 or 48. So static number 6, hybridization sp3 d2. So geometry is octahedral. Shape is equal to geometry, and it is also octahedral because lone pair absent. Clear? Now I am going to show you the shape of this molecule. Look at carefully, huh? Very simple, don't worry. Very simple. Okay. This is octahedral structure. See, first I will draw it here, then only you can understand. I will draw it here. SF4, right? SF4 down. SF. Okay. This is S. So this is on the plane. This is above, and this is below. Okay. Put 6F. 1, 2, 3, 4, 5, 6. Let me tell you one thing. Let me show you the angle. Let me show you the angle. This angle 90 beta. This angle 90 beta. This angle 90 beta. This angle 90. Okay. How about this one? Sir, this is 90. Sir, this is 90. Sir, this is 90. Sir, this is 180. Sir, this one 90. Do you get it? This one is 90. This is so confusing. From here you cannot understand. I will show you the model. You can understand it. See, look at it carefully. Okay. Let me do one thing. Let me do one thing. See, this is square plane. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Can you see that? 1, 2, 3, 4. So this is 90. This is 90. This one 90. This one 90. And this one 90. No problem at all. See, black. This one and this one 180. See, here this one 90. This one 90, this one 90, this one 90, and here this one 90, this one 90, this one 90, and this one also 90. Okay, got it? No problem? Okay, no problem at all. Okay, now next move to this one. IF5. Now next move to IF5. In case of IF5, IF5, 7 plus 35. Okay. So 42, 8 times 40. 2, 1, 2, 0. Okay, static number 6 hybridations sp3 d2. Geometry not equal to shape, lone pair present. Okay, up to this it's clear. Now what will be the shape? Geometry is octahedral, no doubt about it. Okay. What will be the shape? Okay, this is square. The shape will be, let me draw that one. So this is I, this is lone pair of electron F, and this is known as square pyramidal. Square pyramidal. Let me show you that one. Let me show you. From axial positions, from here we will just remove this one. Okay. This will give you square pyramidal. Don't look at this one. It's a square pyramidal. This is the square. See, I'll show you. don't look at the lone pair. This is square, and here one atom is there, so that will give you square pyramidal. This is square, and from here it will form a pyramid. That's why it is known as square pyramid. Okay. Now next one. Next one is XCF4, xenon tetrafluoride. XCF4. Total valence electron. 8 plus 4 multiplied by 7, 36. So 4 to 6. Shape equal to geometry, not equal to geometry. Lone pair present. Geometry is octahedral. Shape will be, geometry is octahedral. Shape will be square planar. I will show you that. How? Square planar. Just remove one more. Okay. Okay. Let me draw the shape. This is if one lone pair and another lone pair. So this is square planar. Look at here. Don't look at this one. This is square planar. Angle is 90, 90, 94, 90 degree angles are there. Okay, this is square planar. Now next move to this one. This is very, very important. One of the most important shapes you must know. This is very, very important. I will write very, very important. Pay special attention on these structure, shape, geometry. It will be very confusing. You need to remember some of the things. There are detailed explanations. I am not going into detail. Just try to remember some of the things. Okay? I am going to explain now this one. Okay. First, go for IF7. First, I will discuss this one. Okay. This one. IF7. Better. IF7. Total valence electron will be 56. Steric number 7. Hybridizance sp3 d3. This is pentagonal bipyramidal. So how can we show the shape of this one, pentagonal bipyramidal? Okay, let me draw first this one. Okay, pentagonal bipyramidal. This is pentagon. Okay, this is iodine. Okay, 1, 2, 3, 4, 5. Write it here. 2, 3, 4, 5, 6, and 7. That's all done. Now let me show you the angle. Here angle is 72 degree. This is 144. Okay. This is 90. Okay, no problem. So in case of trigonal bipyramidal geometry, but we have observed that here angle will be more and the plane equilateral triangle. Okay, here angle will be more, but In this case, the angle is less compared to this angle. Okay, what will be the used for that? This will be used here. I will show you XCF5 minus. Okay, this is so here we can write shape equal to geometry lone pair epsilon, and that is pentagonal bipyramidal. Where I have written, I did not write. Okay, I did not write pentagonal bipyramidal. Write it. Pentagonal bipyramidal. Now next move to this one. XCFY minus, very important, very important. Please try to remember this one. Important. XCFY total valence electron. Calculate 8 plus 5, 7 plus 1, 44. So 5 BP, sigma BP plus 2 1. Now question is, where you will put the lone pair of electron? It will be, are they placed in equatorial positions or axial positions? See, look at very carefully. See, when we are writing or we are looking at pentagonal bipyramidal, then it's like, okay, xenon. This is xenon. Okay, like that. See, wherever angle will be more, we will put lone pair over there. In pentagonal bipyramidal geometry, never put lone pair of electron here because angle is here 72. Lone pair will be placed over there where the percentage of S character will be more, and angle where angle is more, percentage of S character is more. যেখানে angle বেশি সেখানে এটা লোন পেয়ার অফ ইলেকট্রনকে প্লেস করব। ওখানে কিন্তু আলাদা ছিল, ওখানে কিন্তু ভাই 120 ডিগ্রি অ্যাঙ্গেল ছিল, তাই না? ওখানে 120 ডিগ্রি অ্যাঙ্গেল ছিল, দ্যাটস ওয়াই we placed lone pair here. In this case, two lone pairs will not be placed here because angle is very less, 72. Rather, the lone pair will be placed better here. Okay, lone pair will be placed here. These are the lone pair, and this shape is known as pentagonal planar. What? Pentagonal planar, like square planar. In square planar, what we did? Okay, A, say lone pair. This is lone pair. B, 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 B. That's it. So this is square planar. This is pentagonal planar. Very important shape. Just remember this one. Okay, very important. Now, one of the most important that do not do that. In this case, that sp3d3 means pentagonal bipyramidal geometry. Never. Up to now, for any hybridations, the geometry was fixed. But in this case, it will be different. There are detailed explanations. Contractions, flexional. I am not going in detail. Later we will discuss in separate segment. Now you just remember sp3d3. Here 6 bond pair and 1 lone pair. So you might expect that the geometry geometry pentagonal bipyramidal, and shape 1 lone pair is there, so shape will be pentagonal pyramidal. Shape will be pentagonal pyramidal and geometry will be pentagonal bipyramidal. No, this is blunder. Don't do that. I will show you the shape. XCF6, if you calculate XCF6 beta, you will get sigma BP, you will get 6, and lone pair you will get 1. Okay. Now look at it very carefully. When I draw the shape of this molecule, and geometry will be very interesting. See, for F6, what will happen? Here, this lone pair is basically stereochemically, it is known as active lone pair. Active lone pair means it will take part in hybridizations. Not all the lone pair of electron will take part in hybridizations. Later I will show you here. So this is stereochemically become inactive lone pair. Sorry, active lone pair. In this case, it's active lone pair. How will be the shape? Let me draw it. Okay? Let me draw it. Okay. This is X. 1, 2, 3, 4, 5, 6. As it is stereochemically active lone pair, what it will do? It will basically, sometimes it will arise from here. Okay? কখনো এটা এখান থেকে আসবে, মানে লোন পেয়ার স্টিরিওকেমিক্যালি অ্যাক্টিভ লোন পেয়ার কখনো এই ফেজ থেকে বের হবে। ওকে, কখনো বেটা ও এখান থেকে এলো, কখনো বেটা এখান থেকে এলো। It will be in equilibrium. কখনো এখান থেকে, কখনো এখান থেকে, কখনো এখান থেকে, ডিফারেন্ট ফেজ থেকে রাইজ করবে। একবার এখান থেকে, একবার এখান থেকে, একবার এখান থেকে, from the different phase, একবার এখান থেকে। হলো, এতে হবে না। What will be the geometry? Better. When we will talk about geometry, we will count the total pair of electron, means sigma bond pair and lone pair of electron. That will give you 7. Okay, 7. See, if you remove, say, this is octahedral, right? This is octahedral, right? Right? This is octahedral, and you put one lone pair over here. So what will happen? What will happen? It's a like this one has a cap. A lone pair is here like a cap, and that's why this geometry is known as capped octahedral. Capped octahedral. Okay, I'll write. Geometry is capped octahedral. Capped octahedral. Okay, very very important. Capped octahedral. The geometry is here, beta, capped octahedron. Okay, I'll write it more clearly, like, okay, let me, okay. This is X. If lone pair I am showing here, sometime here, you could show it. Okay, it will be in equilibrium. That's why its mu will be almost 0. I mean dipole moment is 0. Later we will discuss this one. It's a very interesting molecule, dipole. So geometry is capped octahedron. Capped octahedron. No problem. Till now it's clear. Okay, what will we say? Hey, if there will be a lone pair of electron, beta, if there is one lone pair of electron, lone pair of electron here, I am showing only here. If lone pair of electron present, then what will happen? See, in this case, you just look at here. Now, if lone pair of electron will be present, then what will happen? Distortions arise. See beta, lone pair of electron present here. So lone pair repel here, repel here. So like it won't be the perfect octahedron. Angle won't be like 9 here, here like angle won't be 90 degree. It will be distorted like this. It will be distorted. That distortions arise due to presence of this lone pair. That's why the shape is distorted octahedral. Shape is distorted octahedral. But clear? Very, very important. Please remember this one. This one. D3. In case of this molecule, ICl6 minus. Please remember these examples. ICl6 minus is BCl6 minus and TBBr6 minus. In case of ICl6, what will happen? When the size of, expected, if you calculate the total valence electron, then 7 plus 42 plus 1, 50. So we just divided 8. 6 bond here plus 1 bond here. This is the drawback of base pair. From base pair you cannot predict this one. Base pair we will get means BAC pair, valence electron pair repulsion theory. You will get simply 6 bond pair and 1 lone pair. But whenever the structure, whenever the bonded atom will be bigger in size, what will happen? You just see. What will happen? You just see. Draw this one. Like this is I beta. This is Cl. 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 And this is Cl. One lone pair of electron that will be basically stereochemically inactive lone pair, considered as stereochemically inactive lone pair. In this case, what will happen? Okay, let me put the lone pair of electron here. Here, this is the lone pair of electron. See, if it try to come out from any one of the face, because of larger size of Cl won't allow. Cl won't allow to come out this lone pair. This lone pair is known as synced lone pair. Sync, you please remember. Or this lone pair we can write here. This is buried lone pair. B-U-R-I-E-D, buried lone pair. Okay, synced lone pair or buried lone pair means Cl won't allow to come this lone pair out. যেমন আছে তেমন তুমি থেকে যাও ভাই, don't try to come out. Please be happy with the way you are. We won't allow to come out means it will be stereochemically inactive lone pair, which is also known as synced lone pair or buried lone pair. So what will be the geometry and what will be the shape? See, if this lone pair do not take part in a hybridization, and this hybridization is known as P3D3 hybridization, because S electron of iodine do not take part in hybridizations. So here geometry will be beta. Here geometry will be. Let me write here. Geometry will be perfect. Geometry will be octahedral, and geometry will be octahedral, and shape is also octahedral. Here geometry is equal to shape. Here geometry is equal to shape. Okay. Did you get it? Please pay attention on these 3-4 structure 1, 2, 3, and try to remember these one. You must remember the buried or synced lone pair. sp3d3 hybridization does not mean that it will give you the pentagonal bipyramidal geometry. No. Sometimes it will give you pentagonal bipyramidal. Sometimes it will give you octahedral. And from the whisper, the way you calculate the bond pair, sigma bond pair and lone pair of electron, if you fall into that trap, if you don't study in detail, then you just simply do the mistake here. Here try to remember this is synced lone pair or buried lone pair. Do not take part in hybridizations, and hybridizations will be P3D3, means these lone pair do not affect the bond angle, means no distortions. So geometry will be the same. So here geometry will be octahedral, shape will be also octahedral. Okay, thank you so much.